Bueno, gracias a todos los sponsors por traerme a Barcelona, que es una de mis ciudades favoritas del mundo. Así que gracias. Now I will switch to English because my talk is in English. I have not rehearsed it in Spanish, so I don't have a clue how to say half of the words in Spanish. So sorry for that. But I can answer questions in Spanish and Spanglish it. So my talk is about GraphQL and serverless, and I call it a match made in heaven. And it's a very nice romance story about two technologies that love each other, and they are made perfectly for each other. So I'm Marcia. I work at Robio as a full-stack developer. I've been working there for 5 years. Robio, if you don't know, is the company that makes the Angry Birds. So Angry Birds is a Finnish company, and I've been working there. I also have a small consultancy where I help companies to start with serverless and migrate to serverless and train in serverless, so I do a lot of that. And I have built many courses, and I have a YouTube channel called Fubar. So if you want to get started with serverless, you should definitely check it out. I have around 160 videos on AWS and serverless. So yeah, that's me. So follow me on Twitter if you want to get a lot of spam about serverless. So if you have been in software either as a front-end developer or as a back-end developer and have been using REST endpoints in your work, maybe you have seen something like this. When REST endpoints are not well-defined, or they might have some, I don't know, old endpoints, versioning starts appearing. And versioning is OK when you have two versions, but sometimes you get 1.2.1, 1.222. Like how you kind of start versioning an API is a minor change, is a big change, I don't know. When you're using that API, is this the last version? Should I migrate to the latest version? What is the big change? Will my endpoint work forever? I don't know. That's kind of a problem when you're using REST. Also, sometimes it's things like this, that you are a creator of an API, and you don't want to share all the information with the world, so you create an endpoint for your internal application that shows all the order, for example, and then for some of your clients that only shows the description, so you create a new endpoint that shows the description, and then you create a new endpoint that shows the items for a different client, and then at the end of the day, you have 27 different kind of similar endpoints, but not fully the same. And as a maintainer, that's a pain in the ass. And as a consumer, also, it's very hard to know which one is the one that you need to use. And sometimes it's the other way around. You have one endpoint that sends a lot of things, and there's so many things that the client basically is fetching a lot of information that doesn't need. It just needs the description. So the client is getting overload, is getting a huge HTTP response that it waits a lot of space in your memory if you're using a mobile phone that takes a lot of battery and is pointless. So lots of information back is not good. Asking for specific information with a lot of endpoints is not very practical. Also, sometimes as a consumer, you need to call 3-4 times to populate all your views. So you need to get the order, then you need to get the provider, then you need to get the customer, for example. And that's only to populate one view in your screen. And that's free HTTP calls and free calls to the server, free waits, free responses, and maybe you're getting a lot of information you don't want. So yeah. Have you seen bad documentations in your APIs? What is the headers? What is I'm getting back? I don't know. Sometimes the object that is coming in one response is different from the object I get in from a different response. So it's kind of hard if the APIs are not properly written. Sometimes consuming that type of REST APIs and maintaining those types of APIs makes your head blown into pieces. If you're a consumer, you don't know if those APIs will be maintained for how long. You don't know when to change them. You don't know if you're really calling it right. If you're a maintainer, you need to test a lot of endpoints to make sure that everything works fine. And you need to keep a good track of all the life cycle and all the different clients that are using all the different APIs. There is kind of a lot of pains. Now a little story. So I've been working as a backend developer for like 15 years, so I'm very old. No, I started very young. And I started this project at Robio. That was my first GraphQL project. So I joined this team. It was a very small team that already have set up everything for me because I joined later. So they have 2 backend developers, 1 Android guy, 1 web guy, and 1 iOS guy. Well, there were girls and guys, but I just call in guys in general. It's a nice team. Rovio is a very diverse company. And there they have this GraphQL backend where the clients were consuming these GraphQL APIs, and the backend was done in whatever the backend developers were liking. And the interesting thing of this project is that we have around 16 different clients. So this was a video application, and this video application we have produced our own clients. So we have our mobile, iOS and Android, and also our web. But then we have third parties that we hire. So if we wanted to make a Roku, that is something that in the US they use, we hire a company that specializes in building Roku TV, and we give them the API, and they will build the application for us in whatever technology they do. The same with Samsung TV and other kind of smart TVs that they have their own proprietary APIs to build their things. Also, the games were integrating to our platform. So we just have a lot of games that were integrating in very strange ways. Some of the games were picking like which videos they want to show. Others were having like playlists. They were doing whatever they wanted. And as a backend developer in that team, it was very nice to have this GraphQL thing, because we really didn't need to worry too much of how they were using our API. Our API was standard for everybody. It was secure. And I will show you a little bit of all these characteristics in a moment. And it was very simple for us to maintain, because we can add things, because GraphQL has a system in place to evolve your API with time, so you don't need to create versioning, and you don't need to manage a lot of those things. And then later on, I wanted to try to be an iOS developer, because the iOS developer left, and I joined the other side of the table as a consumer of the API, and I found that GraphQL was really cool, because you already have everything documented in the proper API, so you didn't need to rely on some developer that was very busy on writing exactly all the documentation. So it was pretty straightforward for me as a consumer to use it. So I think for me it was a great discovery, and I hope this talk also opens your eyes if you have not used GraphQL on how amazing it is. But this is not a talk about trashing REST. I use REST for 80% of my projects, so it's not that I hate REST. I think REST is great, and GraphQL is great. You just need to use the right tool in the right place. So don't think that I'm trashing REST. I love REST, but I have seen so many wrongly defined APIs that sometimes GraphQL is the right tool to go. So that's something you need to decide in your project if it's the right tool, and sometimes it's REST, sometimes it's GraphQL. And after I give a little brief description of GraphQL, I will move on to the serverless part of it. But I think it's good to start with what is GraphQL. If you don't know about it, it's a specification. It's not a database, it's not a system, it's not a server, it's not a framework, it's a specification. Somebody wrote it, open source it, somebody Facebook, meaning put it on the internet, and whoever wants can implement it in whatever way they want it. It has kind of two parts, a query language and a runtime. The runtime is a specification again. It's not like hard-coded runtime. Well, it will turn into one, but it's a specification of a runtime. And the query language is a definition. So some of the characteristics of GraphQL is your client asks exactly for what they need. And I love that. If you have a lot of clients, as we used to have in our project, then the client you don't need to provide a special endpoints for them or give them all the information in one call. So the client can ask for the name and the height of this hero, and if they want later the mass, and they will get exactly that. And you can remove fields if you want later or add more. And GraphQL supports that. So that's pretty nice. Then you can get many resources in one request. So you don't need to call your backend 3 times for populating a view. You just ask for all the resources in one request, and then you get it in one response. Nice and fluffy, as we like it. Next, it evolves your API without versioning. It has tools like deprecating fields and kind of hidden fields that you can use in your definitions. So then it's backward compatible for your old clients, but then you can also let know the new clients don't use this field has been deprecated. And it's easier for maintaining later on, because you can keep a set of tests not like 2 million different endpoints that you don't know who is using, and you need to add tools to manage that. Then one of the best things of GraphQL, that is a strong type language. So you will define everything in one schema. That is all your types, basically. In this case, we have the character, the planets, the species, and then you will put the fields inside. What are the properties that are available for each of these types? And then you will define all your possible queries and your mutations, and I will go into that in a second. And this is shared between the client and the server, and this is your documentation. Sure, you can add better documentation by providing more information on what exactly is happening, but just with this, your client, if it knows what your API is about, can start using it right away. GraphQL can connect to multiple data sources, so it's something that goes between your client and your kind of whatever is your server. We can call it server, meaning it can be a database, like a SQL database. It can be an existing server. It can be a Lambda. It can be a non-SQL database. It can be an HTTP service. It can be whatever returns you something, like, I don't know, Elasticsearch, if you're doing some weird search thingies, whatever you like, you can connect GraphQL to. And you have multiple of them, so you can bring different parts of your response and build them with different kind of information that come from different places. So that's pretty neat. And also, you can provide HTTP responses in parallel with GraphQL, because GraphQL is just one part. So if you have some server-to-server connection that you want to use HTTP REST, for example, then you can have another part of your system that just return that and keep your GraphQL for client. So GraphQL is just an intermediate middleware there. Let's talk about the query language. So everything is a type, strongly typed language. So everything is a type. And types have like scalar things, like the fields can be strings, integer, booleans, I don't know, those basic things. And also can be types. So you can have, like for example in this case, video has channels, and channels is an array of channel. And channel has 2 fields. So you can define whatever you want with that. It's like basic JSON, for example, kind of idea. And then we have special types. We have mutations, queries, and subscriptions. Queries are operations. These are all types, special types of types, because everything is a type. But queries are operations that you will perform in your data without side effects. So basically reading your data. Mutations are operations that have side effects, writing your data or doing whatever you want, but in general it's writes. And subscriptions are the interesting part, because it allows you real-time kind of update from your client. So this is something that is not available in all the platforms, and you need to implement it, because a basic HTTP request doesn't provide two-way call. So if you implement GraphQL in a simple HTTP service, this might not work. But if you are using WebSockets, for example, or MQTT or whatever as a protocol, you can use subscriptions. And subscriptions allows the client to ask, the server to provide information to the client. So basically when something changed, I don't know, I have a new hero, then the server will tell all the clients, hey, there is a new hero, update yourself. And then the client doesn't need to poke the server every 10 minutes. Hey, do you have something new? Hey, do you have something new? Because that's in general how we do HTTP web applications, that we are asking, hey, hey, hey. But in this case, it's not. It's the other way around. The server will just talk to the client whenever there is something new. And for that, the client needs to subscribe to this special operation. So there will be a special operation there that says, let me know when there is a new hero. The client will subscribe to it, and then the server will let you know. And these are really, really interesting. Queries are in all GraphQL's applications. So in general, we need to find data, and that's why we write the application itself. Mutations are in general in 80% of the GraphQL things, and subscriptions depends on how you implement this, because you can have a totally function GraphQL application without subscriptions. So basically, the client will write something like that. It's a JSON query, give me all the videos with the ID and name. And then the server will exactly return a JSON with what they need. So an array of videos with ID and names. And then if videos, I don't remember what it's in there. I think it had URL and channels. So if later on the client wants to ask for the URL, it just adds in the query URL, and then all the future responses will contain the URL. So this is just a brief introduction to GraphQL. It's a very complete language. This is the URL where you can go for free and start learning. It has a lot of resources, and I recommend you to go there and take a look if you're interested. It's really easy to start, and you can try this online with no cost, so it's really cool. Let's talk about the runtime. That is the magic sauce. The first thing you need to do is describe your data using this kind of query language. You will create a schema that is called, and that's your types and your fields, your queries and queries operations, your mutations, mutation operations, and subscriptions operations if you have. Good. Then you connect your data source. Data sources, as I said, can be anything that returns some data. And in GraphQL, there is kind of two parts that are kind of proprietary of your own application. There is the data source, specification, and then the schema. The schema is your own business logic, business, whatever your business data or whatever you need. And the data sources are all your different data sources that they're very specific for you, so you cannot like find online, okay, I want to fetch this table of video. So the data sources means that you will need resolvers. I will talk about those. That is the connection between the GraphQL and the data source. So for example, if you have a table, this is a SQL table, this little arrow will need to know how to open a connection with the database, will need to know how to do a select, star, from, videos, and then it will need to understand how to filter those parameters that you want and return them to the GraphQL. So that's very proprietary of your own application. Then the client will ask exactly for what they need, and the server will fetch it for the right data sources. In this case, it was a video that we were asking, so we will go to the video table, and then it will return the data to the client. Data sources, as I said, can be anything, so you are not limited to that. But if you want to write your own data sources, you need to remember that you need to write your resolvers. The resolvers are these things that I was saying, these instructions from GraphQL to get the data from the data source. So this resolver will be the SQL one that will open the connection. It will do the select all. Or if you are using an HTTP resolver, you will need to connect to some specific endpoint with some headers and create the HTTP request and then parse the HTTP response into something that is GraphQL friendly. So the resolvers are very specific for your own application. That, the schema and the resolvers, don't forget that. That's the most important part of your GraphQL application. The rest is the same for all of them. Serverless. Already Magda gave an introduction, so I will go very fast. So free promises from serverless. No managing of infrastructure. You pay for what you use, and I like the word automatically scale, up and down. And basically, it's two things. Serverless, in my opinion, the functions as a service, that is our friend Lambda, or whatever platform you're using, Google Functions, Azure Functions, whatever, Slack functions, GitHub has functions. And then the backend as a service is the other part that is the kind of, I would say, the most common part of a serverless application. So you see the cake is very big in the backend as a service, and then there's a little bit of function service. So the backend as a service is all these managed services that go through these free promises that I have talked here. So for example, it can be an authentication system that, I don't know, Auth0 or AWS Cognito, or there are millions of that you just connect your application through an API, and you use that service. So if you're using an authentication system, you don't need to build your own authentication management, your database for users, how they forget their password. You don't need to build that. The Auth0 or Cognito or whoever is building one of these will provide all that. So you just have an API that you install the SDK in your application, and then you do auth.sign up, pass the information for signing up, and then you get, I don't know, a token or something back from the server, whatever is that server, is managed by Cognito, for example, and you use it. And you don't need to build an authentication system. The user forget the password, then you do auth, forgot password, user email, and user, I don't know, whatever is in the API. And that will take care of sending the email, asking for resetting the password. You don't need to handle that. And that's the magic of backend as a service. There's a lot of different backends as a service. You can have authentication, as was given the example, but you can have also databases. For example, DynamoDB is the managed platform from the managed database from AWS for NoSQL operations. It provides the same. You use an API in your code, and you're able to put data, return data, query data, do all kind of operations in your database without installing the database, without updating the database, without managing the database. Anyhow, if you don't have traffic, you don't pay for anything. If you have a lot of traffic, you pay for the traffic. The same with storage, the same with queues, the same with streams. Whatever service you imagine, there is a managed service for it. And it's called backend as a service. Usually applications are a collection of these backends as a service, and then functions in between to glue all these services together and to provide the business logic for your application. So basically, you don't need to reinvent the wheel all the time. You just build what is specific for you. So Magda already talked about Lambda, so I will not go into that. And it's important to know that serverless is a spectrum. It's not black or white. So you are not serverless or you are serverless. You can have part of your application can be using Lambda and managed services, and then you can still have servers. And it's OK. For some use cases, you still need servers. So it's not like, oh, I'm fully serverless. You can be fully serverless, and that's cool. But it's not something, a competition that you need to be serverless. So you can, and there are many services that are kind of in the spectrum of serverless. So for example, if you are using AWS, there is the relational database services that it's kind of in the middle of being serverless because you need to manage the instances, but still the instances are not in your possession, in your basement. So there is kind of some degree of serverlessness there. So remember, serverless is a kind of buzzword from the marketing people. So don't buy into something like, yay, serverless. I love it, but don't. It's not something that just, it's a marketing word. It's cool. So benefits of serverless, you pay for what you use. You don't need to reinvent the wheel. You focus on your business logic. You can do very fast development, so things that were taking you forever. So for example, going back to my application with Robio, that we have this backend service, we migrated from being a traditional server application to being serverless. We had 2 backend developers, and it took us like 4 months to migrate a full application that took 5 years to build, because we were able to reutilize so many components that were already in the AWS platform that it was amazing. So it really gives you a fast way to move forward. And but in the other hand, you're building a distributed system, so you need to understand how distributed architectures work. So it's not like magic one that you will just migrate. Yeah, it's all about providing value at the end of the day, serverless. I like this line because I don't like coding. I'm a coder, but I try to avoid it as much as I can. So I try not to write as much as code, because you never need to you always need to maintain the code you write. So I love deleting code. I'm that type of person that will go to your GitHub repo and kill half of it. Yeah, so that's my motto. So now let's talk about serverless and GraphQL. So there is kind of 3 ways on the path to serverless. The first thing is GraphQL is a specification, so you need to write it. So you can go the hardware, that is to write your own implementation of the specification. You can put it in a server, either in your basement or in the cloud, doesn't matter. And there you will need to write not only your you will need to write your resolvers and your schemas, but you also will need to write all the logic that comes with building the GraphQL server implementation. That is not just easy. You need to manage this JSON coming in, and the request, and the parsing, and all these kind of things that all GraphQL applications over the world are doing. But some people have wrote their own GraphQL server. Then you need to maintain it and put it up. So if there is a lot of traffic, increase it, decrease it, and all the pain of managing your own server. Next step in going to serverless world is to use a library. So for example, if you use Apollo. Apollo is a GraphQL library, one of the most popular ones. You have the client version, and you have the server version. So you grab that, then you write your data, your resolvers, and you write your schema. And the whole magic of GraphQL is already in Apollo, so you don't need to implement the server by yourself. You just write your value, your business logic, the important thing, what is unique for your application. But then, this is the most common way of using GraphQL, is installing it in a server, in the cloud, in an instance somewhere, and then managing that instance. But that's not the way I recommend it. For me, the best way to use GraphQL is to use an existing GraphQL platform. That means somebody already grabbed that library for me, install it in a server, and manage it for me. And I just write my schema, and I write my resolvers. And that's all I care. When you're going this way, you have a lot of limitations, because GraphQL can be implemented in any language you like. So if you want to implement GraphQL in Haskell, you can do it. If you want to implement it in assembler, go for it. But if you are using a platform, you need to go through the languages that the platform supports. So for example, some of them use very weird templating, and you need to suffer with it. So as always, the more managed you go, the more restrictions you have, but also you always need to balance what is the most important risk that you want to take. Do you want to take the risk of managing something that is not really important for your company, like doesn't provide any value? Or you want to focus on your application, or you want to write a GraphQL server in assembler? I don't know, what is your business? You just do whatever you think that is the right call. And all of the free answers are good. There's many existing GraphQL platforms. So Apollo, that is the most popular library, has written their platform. So you can go to Apollo platform, sign up, write the data source, write your GraphQL schema, share it with your clients, and then write your resolvers, and then connect to your data sources, and voila, it's working. There is GraphQL CMS, GraphQL Cool, and I'm sure if you Google for GraphQL platforms, you will find millions. I will talk about AppSync, that is the AWS GraphQL platform. So AppSync. AppSync is a managed GraphQL. It's a backend as a service. It's owned by AWS. And it's amazing because as it's owned by a cloud platform, it's integrated already with a lot of the cloud platform services. So out of the box, you will have authentication, connection to the different kind of tables like DynamoDB, that is the managed NoSQL database, connection to the different kind of, I don't know, Lambda. It goes very easy. So you can connect to many, many different services using AWS. Also, if you are familiar with AWS, you will have the knowledge of how to manage the permissions, the roles, the security. So it's something that is familiar to you. It's not something you need to learn again. I've been using this for like, I don't know, 6-7 months. It's pretty new, and I totally recommend it. So this is what I was saying, and it supports real-time. That's the subscription part that I said is not available in all the implementations of GraphQL. This is available in AppSync. You can create subscriptions, and it works. And it also provides offline support. So if your clients do modifications in the data when they're offline, it will sync it automatically on the back when they go online. So that's pretty neat. Also, it provides out-of-the-box authentication with Cognito and other ways of authentication. So you can create your username, your user database, and then give them access to your application. So you can build an application, I think, in less than a day. You can have a very functional, scalable application working. It provides a visual tool for queries, so you can play with it without giving it to your clients, without building a client. So that's pretty neat, but I think that's available in all the platforms. It connects automatically out of the box with DynamoDB and very easily with other data sources from AWS. And if you want to use something that is not AWS, you can always do an HTTP call, and it works. So basically, it's the same steps as with the runtime. You create a schema, you connect it with different data sources, and voila, it works. So let's see it in the console. So this is what you will see when you create an API from scratch the first time. So you can either go for the create wizard, or you can create a sample project. I will create a sample project so I can show you more or less a little bit the view. So this will take a little while. It will create Dynamo tables. This is a project where there is events and comments. And this will create two tables, one for events and one for comments. And it will do all the magic there. It will create the resolvers and the data source connections. So if we go to schema, we can see the schema that is created automatically. So these are really cool to start learning GraphQL because you can see the different parts of a working application. So you can see the comments, you can see the event. Here you can see the mutations, the create and the delete. And then the queries, the get and list, and the subscription as well. And there's a lot of shit that you need to learn when you're doing GraphQL. These are the resolvers. So these are the fields connected to different data sources. And there is the tables, the data sources are the two tables, the comment and the event. So everything you can see from the console, and that's pretty nice. And here I open the table, and it's empty because we just created it. But now we can go to queries. And we have two queries defined here, but you can create any queries you want. These are example queries for lazy people like me. You have the list event and the create event. So if you just create an event, it creates a new event. And if we go to the table and refresh it, it's poof, there. And then we can do the list of events, and that will bring the events from the data, from the table. So it's pretty straightforward. And if we remove fields from the results, we will see that they are changing. And in the settings, you can see all the information you need to provide to your client to connect to this backend. So if we give the URL and the API key in this case, then they will be able to connect to this backend, and you shared also the schema, and start creating queries to this event comments. So it's pretty fast. This was more or less in real time. I think I speeded up a little bit, but it's very fast. If you want to build a Hello World application, it will take you like, I don't know, from 0 to something, maybe 3 hours to have a client and a backend and everything scaling up. So it's something really fun to start working. And from production, I will not recommend you to go to the console, but you can build all of these as infrastructure as code as well. So you can use CloudFormation, and you can build everything as CloudFormation, and that's how I will go and how I go to my production. So it's really cool. And the resolvers in AWS AppSync are velocity templates. So if you have been using Java, it sounds pretty familiar. If you have not used it, then it's very easy. So you have to learn that kind of language, templating language, to start using AppSync. Because as I said, when you're using something that is made by someone else, you have to go with the restrictions. But velocity templates are pretty easy. And if you cannot find your way around velocity templates, you can always create a Lambda and do all the magic in Java, JavaScript, Python, or your language of choice. It's very easy to maintain in general because everything is centralized in there. And you will see the connections to all the different managed services. And if you're using infrastructure as code, you can try it in different environments pretty easily. Your applications are secure out of the box if you're using services like Cognito. You can create fields that are only available for specific customers with the specific roles. So you can create like an order, for example, the first example, and you can show the order description to everybody, but only show the order items to specific people with specific roles. So all that is in there out of the box with the connection of AppSync and Cognito. So it's pretty neat. And it's very scalable because it's a serverless service, and you pay as much as you use, so it's pretty neat. So if you have any questions, go ahead and ask, and I'm about to launch a course, so if you want to learn more about that, you can follow me on Twitter. So if you have any questions, shoot.
Not for questions, who didn't want? Remember about the bottle?
I'm tired, I speak very fast and I don't have time. Shit, I'm very, very tired. You might be exploding right now. In Spanish or in English, you choose. Okay.
What is your recommendation for define or best practice to data sources?
Data sources, if you're using AppSync, I would recommend to stay in the AWS offering of serverless data sources. So Dynamo is the best choice if you have a database for AppSync. Why? Because if you're inside the AWS kind of world, it's using the same data center, so the traffic goes internally, it's very fast, and you improve your performance. So you don't have to go to the internet because you can build data sources anywhere. So you can have, I don't know, a table in an instance somewhere, and you can do an HTTP call. But that will go to the internet from Amazon out to the internet, and then in again to Amazon. And that's time that your client will be waiting for responses. So when you design these distributed systems, you always need to think about how to minimize the time between the different services, how to minimize the latency of your request, because you will be using different services and you need to glue them together. So a good practice is always to use the services of the platform you're using. So that's why it's cool, the AWS AppSync offering, because then if you already have all your services inside AWS, then it's pretty easy to get started. If you use an external platform, then you will always need to go through the internet, and that adds always the latency of an HTTP request and response that is extra for your client to wait. So my recommendation is try to go to data sources that are inside the same platform that you're going through.
Yeah, I think that was good. Thanks for the talk.
Where is the question?
What would be your recommendation to do the same on Google Cloud Platform?
I don't have a clue. Sorry for that. I don't know if Google even has a GraphQL thingy. They have Firebase, that is kind of the closest thing that you can go. But I have not used it in production, so sorry for that.
Hi, thanks for the talk. Just one question.
Sure.
In experience, how do you manage the mapping between the clients asking for information and including some fields or excluding some others, and the server having those fields in the database? Do you have any application layer in the middle, or do you allow the clients to directly call?
GraphQL is the middleware. So in there you will build if you have some private fields that only some specific users can see, you will build that, for example, in your velocity templates scripting. There you will build, okay, this email can only be seen by its own person. So for example, if you are creating a profile, you will see all the information from the profile. Everybody connected to this application, like in Twitter, will see your profile, but then the email, you can only see it yourself. So you can build that using the velocity templates and the Cognito together. Yes.
Okay, so the last one.
And you can ask me outside. I will be for the coffee break. So.
What about performance?
Performance is a pain in the ass. No. And it really depends on the platform. So here we go again to try to use the service that nothing is a magic bullet that will solve all your problems. So in the case of AWS, you need to.
Sorry, I mean, between a plain REST server and.
It's the same again. It's not about the performance between REST and the performance between GraphQL. GraphQL is a layer in the middle. So usually when you create an HTTP response and request, you have a connection directly to your server. So you are avoiding a middle guy there. But you need to design, in general, systems, if you are building a serverless application, with the latency in mind and the connection between the different services in mind. And I think that's very, very important when you're building serverless applications. Not only GraphQL, but when you're using Lambda, you always need to think about what is the kind of latency between different services. If you're going to the internet, what is the concurrency that each service can take? So think about that, and that will impact in your performance. So it's a tricky question, and all the different applications have different answers. So for example, in some cases you can use storage objects, so you can store there, or you can use even a cache, or you can use some distributed caching, or have some kind of database in the middle that manages the call. So depending on your application, the ways that you will handle how you can make your request faster and how you can architect your application to respond faster. But it's one of the trickiest things, I think, in the serverless application design to improve performance.